Hello, everyone. Today we are going to do vertex form of a quadratic. We've been working with what we call standard form, which is ax squared plus bx plus c equals f of x. Today we're going to talk about vertex form, which is f of x equals a parentheses x minus h quantity squared plus k. And this is convenient because we can easily identify the vertex. The vertex is h comma k, where h is the horizontal shift and k is the vertical shift. A vertical stretch will occur if a is greater than 1, and a contraction, meaning we'll squash it, if a is between 0 and 1. A reflection over the x-axis if a is negative or less than 0. So here's how we can use this. Example 1, given that function, y equals x minus 3 squared plus 2. I can look at that immediately and know that the vertex or the turning point is 3, 2. Because it matches that. Determine the range by drawing a rough sketch. So I can determine the range by knowing that 3, 2 is my turning point or my vertex. A is positive, so that means it goes upwards. So this is roughly this right here, where this is my vertex, which is 3, 2. So the range is y is greater than or equal to 2, because 3, 2 is a minimum. Now, the question then is, how do we take a quadratic equation in the form y equals ax squared plus bx plus c and put it into the shifted form or vertex form? We're going to use completing the square. So let's review when we're talking about perfect square trinomials. So I want you to pause and I want you to do A, B, and C and come back and check. So when we do x plus 5 squared, that means x plus 5 times x plus 5, and some of you will do the double distribute. However, if you recall, we talked about that when we are squaring a binomial, we can do that by squaring the first one, then multiplying and doubling. So I'm going to do 2 times 5 times x plus the last one squared. And so that gives me x squared plus 10x plus 25. B should be x squared minus 2x plus 1. And C is x squared plus 8x plus 16. So now, given that I have a trinomial in exercise 2 in that form, what is true about the relationship between B and the value of C? So also recall what we did yesterday is that C is equal to B divided by 2 squared. So we learned when we were completing the square that we first of all make sure A equals 1, we do B divided by 2, and then we square it. So if I look at question C, 8 divided by 2 is 4. And then I square that, and I get 16, which is the C value. So now we're going to, each of the following trinomials is a perfect square. Write it in factored form. So I want you to factor each of these. So pause and do that. So this is x plus 10 quantity squared. This is x minus 3 quantity squared. And this is x plus 1 quantity squared, because they're all perfect square trinomials. So I took square root of 100, which is 10, and I double checked that 10 times x times 2, and I always double it, is 20x, middle term. Again, I took square root of 9, which gave me 3. So 3 times 2 is 6. I need it to be negative, so that means it's negative 3. So exercise 5. This is our quadratic. It's shown, it's graphed. Consider only the binomial x squared minus 4x. What do I need to add on to that to create a perfect square trinomial? So remember what we do is we take our b term, which is negative 4. And we do that divided by 2, which gives me negative 2. And then I square that. So 4. In order to keep the binomial x squared minus 4x the same as the value, what should we subtract to offset by adding the 4? Well, if I'm adding 4, I need to subtract 4. So now I want to use this method of completing the square now to rewrite that trinomial in an equivalent shifted form. According to this form, what are the coordinates of the vertex? So what we're going to do is we're going to take that x squared minus 4x minus 1. Notice I separated it. We're going to add 4 to this part. But then because I added 4 in here, I need to subtract 4 out here to keep it equal. X squared minus 4x plus 4 factored is x minus 2 squared. Negative 1 minus 4 is minus 5. So in vertex form or shifted form, I get this function, which means my vertex is 2, negative 5, which is the vertex of this parabola. Okay, so now let's talk about this, do some more examples of this. Write each quadratic in vertex form by completing the square. Then identify the vertex. So here we go. So again, I'm going to group it as y equals x squared plus 6x plus something minus 2 minus something. These somethings are the same. To find that something, I take the b, which is 6, divide by 2, which is 3, and then square it. So if I add 9, I need to subtract 9. I then group the trinomial, and I'm going to factor that. So that trinomial factored, it's a perfect square trinomial, so it's x plus 3 squared. And then I do negative 2 minus 9, which is negative 11. So the vertex here is now negative 3, negative 11, because I'm comparing it with x minus h squared plus k. So since it's plus 3, that's minus and minus. So I want you to pause, and I want you to write each of these at B and C as a perfect square trinomial minus some other factor. Okay, so the first one, we start out by doing y equals x squared minus 2x plus something plus 11 minus something. Whatever I add here, I need to subtract because I need to keep it equal. So to find what I'm going to add or subtract, I do negative 2 divided by 2, which is negative 1, and then square that. Negative 1 squared is 1. So I add 1 and subtract 1. That gives me this perfect square trinomial, which factored is x minus 1 squared. And then I combine like terms out here, and I get plus 10. So the vertex is 1, 10. Letter C. Again, it's y equals x squared minus 10x plus something plus 27 minus the same number. To find the number, I take my b, negative 10 divided by 2 gives me negative 5, which I then square. So I add 25 and subtract 25. Take this trinomial and I factor it. So that's x minus 5 squared plus 2. So the vertex is 5, 2. So that's the end of our video today. We will pick up doing the last 3 questions, D through F, tomorrow. If you have any questions, please bring them to class.